So in this video, I wanted to show you guys how to do your first energy lab. So the first thing I'm going to do is I'm going to show you how to get to it. So you're going to click on course materials and then content. This is in the energy unit, so I'm going to click energy. Then I'm going to hit this very first link. And what I'm going to do is I'm going to search this gray sidebar to the right until I find the first energy lab. Okay, energy conservation virtual lab handout. That's what I want. Okay, so now that I've got that, I'm going to go ahead and I'm going to minimize that. And I'm going to bring the lab up. Okay. So here's my lab. I need to click on this link to get to the PhET simulation. I'm going to hit download. It's going to download into my downloads folder. I'm going to click on the file. It's going to say it won't let me open it because it's from an unidentified developer. I'm going to go to my system preferences. If you don't have a Mac, you may have to do a different way to get it. And I'm going to hit open anyway. And now it's going to start launching. I'm going to close that website too because I don't need that anymore. Okay, I can close out that. Okay, so it says familiarize yourself with the simulation. Notice how you can change the track. You can give it different shapes. If your skater falls off, you just hit return skater. So I can move it all around, whatever I need to do. Uh-oh, he fell off. I can return him again. I have these different buttons. I can do show path, so that's going to show me where he's going back and forth. I can bring up a measuring tape, something that's going to show me potential energy. I can put a grid in here. That's nice. I'm going to leave the grid. Then I can do a pie chart. So I'm showing how much of his energy is kinetic, how much is potential, and how much is thermal. That's kind of neat. I can do a bar graph. That's going to show up over here, and it's going to do the same kind of thing, kind of adjust it. I can do energy versus position. So it's going to make a little graph like that. And again, it's showing the different colors. And the colors are the same on each graph. So green is always kinetic, and red is always thermal. Blue is potential, and gold, I guess, is your total energy. Then you can do energy versus time. This is nice. It's actually telling me the values at each point. So that's kind of handy. I can say if I'm on space, right, that's going to give me a different gravity. I can say that I'm on the moon. I'm going to clear this path part. I can say that I'm on Jupiter. You can see these gravity values just change for each one. Okay, so I'm going to reset it. Okay, so for the initial experiment, I'm going to click on energy versus position, like it tells me to, and energy versus time. Okay, and I want to set the track so that the middle point is on the ground. And don't change the endpoints. I'm going to leave those there. Okay, and then I'm going to click on choose skater. And that's going to tell me the mass of the PhET skater. So his mass is 75 kilograms. Okay, so I'm going to go ahead and put that here in my data table. And while I'm in this section, might as well fill in the others, right? Okay. Now on the PhET skater. Okay. So I record his mass, and then I'm going to click on measuring tape. So the measuring tape appears on the screen, and I want the initial height of the skater and record. Okay. So I'm going to go ahead and I'm going to put the ground here. I'm going to reset this. Move this back to the ground. Okay, so then it shows his initial height. Okay. I'm going to move these graphs out of the way. They're kind of annoying. So I'm going to see where his initial height goes. Here. Maybe a little lower. So it was like right about here. Okay, so I'm going to do 4.7. Okay. So here's the little red dot they're talking about for measuring his height. I'm going to move this a little faster. Okay, now before running the simulation, okay, so we need to reset it, right? Okay, so he started at the top. Okay, so I'm not exactly sure that was the 4.7, but yeah, I'm measuring it. Okay, 6.33, we'll go with that. Okay, now we want to calculate his potential energy, and we want to predict his kinetic energy at the lowest point on the track. Okay, so his potential energy is equal to mass times gravity times height. Okay, so we can then do 75 times 9.8 times, what do we have our height, 6.33. So we'll get 4,652.55 joules. And we can predict his kinetic energy. Our kinetic energy formula is 1/2 mgh. We'll do or mv squared, sorry. Okay, so his kinetic energy will be 5 times 75 times, and then we don't know our velocity. So let's check these little graphs. Okay, so what I'm going to do is I'm going to actually since we don't know our velocity, I'm just going to use the math. I'm going to start my simulation. I'm going to see what he is at the bottom. Okay, so at the bottom is when our kinetic energy is going to be the highest. So I'm going to look here, and it looks like our kinetic energy was like 3,500. So I'm just going to write that. Okay. So, and I guess what they're getting at, this is our actual kinetic energy. So our predicted kinetic energy, what they're expecting is that at the highest point in the track, all your energy is potential. And so you're going to have 4652. At the bottom, all your energy is kinetic, none of it's potential. So you should have the exact same amount. So that's what they're going to want to do there. So you're not actually going to do any math there. And then you can calculate your velocity. You can use your formula. And then you're going to solve for velocity. Okay. Now, I'll do one of them for you. I'll do this first one for you, but I'm not going to do it in that little box because it's not going to fit. Okay, so I'm going to have KE equals 0.5 times 75 times V squared. And then my kinetic energy was 3,500. My half of 75, I'm just going to put it in the calculator just to make sure I get the right answer, 37.5 V squared. I'm going to go ahead and I'm going to divide both sides by this 37.5. So I get my V squared all by itself. And now I can take the square root. Of 93.33 to get my velocity. And we get 9.66. And that's going to be my velocity. So I'm just going to put that there. Okay, now you're going to want to show your calculations, so make sure you guys do that. And now we're going to, it says it wants to return the simulation to the original setup. So I'm going to reset it again. And then I'm going to click on track friction and set the coefficient of friction to the second line. Okay, so they have it here. It's not the none, not 1 from the none, which would be really the second line, but 2 from the none, which is right here. Okay, then I'm going to run the simulation. Now this one, it just wants you to describe the results, so you don't actually have to do any math, okay? But it does want you to discuss how potential energy is changing, how kinetic energy is changing, and then energy loss. Okay, so in order to see that, you can kind of, you can look through all these different you can look through these graphs to kind of see what's going on. You can show his pie chart. right? Showing that there's a lot of thermal energy here. And then you need to show at least one example of your calculations, okay? If you've already got them up here like you're supposed to, then you don't even have to worry about it. You've already done that question, okay? And that's how you do that simulation.